All right, now we're recording the way I like to record. Okay, so instead of using abstract data, which consists of colored points in a grid, which we did last time, now we're going to use real images that are meaningful. That's what I thought. It's eventually going to complain about my sessions. Okay. And these are going to be, again, these digits that we're trying to label, handwritten digits. All right. So it is bringing down the data and installing the libraries we need. I get set up with the next code while it's doing that. All right, this is going to, okay. So again, we're going to make a small set of samples, including only the digits 5 and 9 to have a simple case to work with. So I'll wait for that one to finish. Okay. And then this one, is it done already? Maybe it didn't really run. There we are. All right. So now here's the training set, which is these images. You know, this is the 784 pixel values. And then there's a validation set. There's, I guess, 100 training and 500 validations. Yep. All right. And a test set of 500. So we have some samples. And now we're going to view some of these images so we can see what we got. There we go. So here you see some of the images. They are handwritten 5s or 9s, and above it is the label that came with it. So this is really a 5, this is really a 9, this one's really a 5, and so on. So that's what we've got, recognizing handwritten digits. Now we're going to define a classifier to do this task and see how accurate it is, as we've done before. All right. And so it's 93.6% accurate at discriminating the 5s and the 9s after some training. All right, so now we're going to perform an evasion attack. It's going to modify some of the images so the model will make more errors. So we're going to use only 25 images, and we're going to calculate using this machine learning model the modifications to make to the image, like to that panda image, that are carefully chosen to confuse the model. So here we go. We were at 93% accuracy. And we're changing some of the test set. Okay, so before the attack, on the test set, it was 100% accuracy on this reduced test set, which I think was only 25 images. But after the attack, the accuracy falls down to 12%, which is, of course, terrible. So these images are extremely poisoned. They're poisoned so that the model almost always gets them wrong. And so let's look and see what it did. This will show all right, there they are. Here's the original images with the original labels. Here's the poisoned images, which it gets wrong. The parentheses is what the model says. As you can see, the model is wrong every time. And again, notice the modification is very modest. A human would never be fooled. All you do is put a couple dots out here, a couple dots over there, a couple dots down there. I mean, this doesn't make a human think this looks like a 5, but it makes the machine learning model think it looks like a 5. The machine learning model thinks this is a 9. You know, why would it think that? It doesn't have the loop up here. It doesn't have the vertical line. And yet this is enough to confuse the machine learning model. So that's an important issue. The poisoning attacks on machine learning models are very different than what humans would see. So there's various things to try here. And you'll see again, here's one, for example, that will miss it. It'll think this is a 2 now because these little bits of snow here, it'll think that's a 2. And it'll think that's a 2 and not a 1, whereas none of those would fool a human. So that's a useful one to go through to understand poisoning or evasion. This is evasion. I keep getting the term wrong. Evasion is when you give it an image to classify after it's trained and it gets it wrong. Poisoning is when you alter the training data so it learns a bad habit. They're similar but different attacks.